Okay, so we're doing VCE 2016 Exam 1. We'll be doing finance, that's what this video will be about, so let's get straight into it. Right, question 17. Consider the recurrence relation below. First four terms of this recurrence relation are, so they've given us the rule here, 3an plus 1, and we have our a0, so all you have to do is put 2 in the calculator, press enter. That's our a0 as shown there. And then we say times 3 plus 1. That's the quickest way to do it. Press enter and you get this pattern. So we want to look for the numbers in order. So 2, 7, 22, 67. So that will be E. So that's your answer there. The value of an annuity after n monthly payments of 555 have been made can be determined by using the recurrence relation this. So this is our rule, similar just to the last question. So all you have to do is type in 100,000 into your calculator, as that is our V0, and then we do times 1.0025 minus 555. We press that 5 times because it's saying the value of the annuity after 5 payments. So there's 1, 2, 3, 4, 5. All I'm doing is pressing enter. So I don't want to copy the number and write the equation. I want to do answer straight away. So all I'm doing here is 100,000. So say for example 100. All I have to do is press enter, and then I say times, plus, minus, divide, whatever. So here it's times 1.002, for example, plus 50. Then I just press enter, 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 and the answers keep coming up. Don't copy and paste the answer, as this won't work. So therefore, after 5 payments here, our answer is 98,467, and that's C. So C is our answer. Question 19. Purchase price of a car was 26,000. Using the reducing balance method, the value of the car is depreciated by 8% each year. A recurrence relation that can be used to determine the value of the car after n years, Cn is what? Okay, so when you get a question like this, you want to look at a couple of important things that I've highlighted. You want to look for your initial value. So that's this, 26,000. That's the initial price that the car was bought. That's why it's C0 or V0 or whatever letter is used in the question. Then you want to look at what type of method was used. So it's a reducing balance method, and we're using a recurrence relation. These two things are really important. And I've got in my notes a page that will be really helpful, which will tell you what to use, which method to use, and what if it's a recurrence relation or an nth term relation. So let's go to our notes here. So we're looking for something with reducing balance and recurrence relation. Okay, so this is a really important page to have in your notes. We're looking at reducing balance method or reducing balance depreciation, and that's can see in here, which means we have a geometric compound relationship. So we're going to use either one of these equations. Now it's either recurrence or nth term. The question tells us recurrence, so that means we need to find what our V0 is and then the relationship here, this equation. So we need to find what R is. Vn is the constant like x, so R is what we need to find to solve the question here. And we have an equation that says R equals 1 plus or minus R divided by P on 100. But because we're using reducing balance, there's the negative sign here. Negative means it's decreasing, so we're going to use 1 minus R divided by P over 100. So going back to the question here, we need to find R. So our equation for R is 1R equals 1 minus R divided by P over 100, where R is the rate, P is the amount of periods compounding, divided by 100. So 1 minus R, 8%, each year, so divided by 1, divided by 100. Now if this said each month, P could be 12, each fortnight, 26. So P can be a number of things here, depending on what the question says. So month is 12, fortnightly, 26, quarterly would be 4. So P can be a number of things depending on what the question says. Each year is really important because that tells us that the period is 1. Do that on your CAS. 1 minus fraction here, 8 divided by 1 over 100. Oops. Enter, control enter, decimal place, and that tells us that R is equal to 0.92. And we know that our equation is R times Vn. So this is R times Vn. That is our recurrence relation here. So we need to look for something in the answers that says 0.92 times Vn, or in this case, it's Cn. So we put Cn there. And that's shown with the first option here, option A. So for question 19, A is our answer. Consider the recurrence relation below. Question 20, V0 is equal to 10,000, Vn plus 1 equals 1.0 for Vn plus 500. Recurrence relation could be used to model what? Okay, so when you get a question like this, there's a couple of things you need to look at. You need to look at whether this number is greater than 1 or below. If this is greater than 1, it means our $10,000 from here, V0, is increasing. And look at this, if there's anything added, it's a plus. So that means this is also increasing, which means anything with reducing balance, I don't even need to read the rest of my options. I just know reducing is wrong. So A is wrong, B is wrong. So I've already eliminated here 2 options out of 5. So I've only got 3 left. What do we know about interest-only loans? Interest-only loans are constant, which means if I put in $10,000 and I get interest, it means my $10,000 is staying the same because I'm taking the extra money out that is compounded from interest. So if I put in $10,000 and I get an extra $100 each month, for example, and I take out the $100 each month, it means I have $10,000 left, yeah? So it's constant. However, I can check this by doing on my calculator. So if I go to my CAS here and I say 10,000, which is our initial, hit enter, times 1.04 plus 500, I click enter, that price has actually gone up. So if it was interest only, 10,000, after I multiply it by whatever numbers are here and add the numbers, the answer would be 10,000. So if the answer keeps being 10,000 or the same number given to you as your V0, that means it's an interest-only loan. So we know from there that E cannot be the answer because we're getting a bigger number greater than 10,000. So our money is increasing. So now we only have C and D left. Okay, so a couple of key definitions that you should have in your notes for your finance section. Here we can see an interest-only loan is a loan where regular payments made are equal in value to the interest charged. The number of payments for interest-only loans can be anything. So it's saying that, for example, the example we were talking about before, $100 is added from interest, the $100 is a payment that's made. So now we're down back to $10,000. Then next month, another $100 is added, then $100 is taken for payments. So we're back down to 10,000. So the loan remains the same. Perpetuity here, we can see similar an annuity where regular payments or withdrawals are the same as the interest earned. The value of a perpetuity remains constant. So this is payments or withdrawals that are the same. So both of these remain constant here. So we want to look for the most obvious answers. And now that we know perpetuity is also constant, C is wrong, which means I don't know anything about an annuity. D is the right answer. So when I'm going through these options, I need to cross out the ones that are definitely wrong, so to make life easier for myself. Look at the things that are wrong, cross them out. Things that you aren't too sure, leave them and come back to them later. Okay, question 21. Janeda invests 80k in a perpetuity. They'll provide 4k per year to fund a scholarship at a uni. Graph shows that the value of perpetuity over a period of 5 years. So what we just said about perpetuities is they remain constant. So that's the key word here, perpetuity, which means anything that's increasing or decreasing is immediately wrong. So as I can see at C, something's increasing or decreasing, don't need to even look at the numbers. C is wrong. D, it's increasing, wrong. E, decreasing, wrong. So I've only got A and B left. So we have two graphs that are showing a constant pattern here. A is showing us that there is only $5,000 invested, but it says 80,000 here. 80,000 is invested. So this is the thing we're starting off with. We're not putting 4,000 each year, we're adding 4,000. So what's actually happening is 80,000 goes up 4,000 to here, for example, then goes back down, then goes up, then goes down. But over each year, it's staying the same because we are investing 80,000, then we're adding 4,000 and taking it away. We're adding 4,000, taking it away. So that's why this is a constant graph, which means B is our answer. A can't be right because it's $5,000 invested, but we've actually invested 80,000, so B is the correct answer. Question 22. First three lines of an amortization table for reducing balance home loan is shown below. Interest rate for home loan 4.8% per annum, compounding monthly, loan to be repaid with a monthly payments of $1,500. So amount of payment number 2 that goes towards reducing principal of the loan is what? So we need to find the principal reduction, that's what we don't know, of payment number 2. So this is what we're looking for here. To work this out, first I want to look at patterns. That's really important with amortization tables, that you find certain patterns. So I can already see that the interest plus the principal reduction, when you add them together, it gives you the payment. So I know that the interest plus principal reduction gives me payment, but I also know that the balance of the loan minus the principal reduction gives me the new balance of the loan. So these are important things to keep in mind. You always want to look for patterns. However, now that I want to find principal reduction, I can say let this equal to X. I can say 249,500 minus X will give me the new balance of the loan. But I actually need another value to find X. So with interest I can't do this as well, because interest plus X I can't solve that as well. So what I'm going to do is use this very important formula here, which is something you should keep in your notes. Interest equals R divided by P over 100 times V0. Basically our R, as we can see, 4.8, and it's saying it's compounding monthly, so that's our period. P is period divided by 12 over 100 times V0, which is 249,500. Now V0 is 249,500 because this is the initial value that we're using to find this. So you're always using the number before, this number here, before, to find the value of the next payment, the next balance of loan. I need to use the previous number. So that's what our V0 is in this case. So when you do that on your calculator, you should get 998. And remember, that's our interest. So 998 goes there. Okay, so now going back to the idea that the interest plus principal reduction gives me my payment. I now know that also 1,500 minus 198 will give me this. So what I'm going to put that on my calculator, and I get, sorry, that's meant to be 998. I get 502. So now I know that 998 plus 502 gives me 1500. That's right. And then now I can say, okay, the balance of the loan subtracted from the principal reduction, that's going to give me 248,998. So that's basically how to fill in the gaps. It all starts with this important equation. So please remember to have that in your notes. So now we're looking for the amount of payment number 2 that goes reducing the principal. So that's 502, therefore B is our answer. Question 23. Sarah invests 5k in a savings account that pays interest rate of 3.9% per annum, compounding quarterly. At the end of each quarter, immediately after interest has been paid, she adds 200 to her investment. After 2 years, the value of her investment will be closest to what? Okay, so this is a calculator question. If you're using a TI Inspire, this is not too hard. One thing you have to note is that whenever someone is investing something, it means the money is going away from them. So if I'm putting money into a bank, it's going away from me, which means it's negative. So invest means negative. Money is going away from me. I'm giving it to the bank, even though it's still mine, but I've just put it in the bank. It's not really with me anymore. So that's how I like to think of it. And that's exactly how the calculator thinks of it. So if I go to my present value, which is what I have, that's my initial. So I have invested 5,000, correct? So it's negative there because I've put 5,000. It's gone away from me. So that's why the present value is what you're starting with. So that's negative 5,000 there. And then pays interest at the rate of 3.9%. So I want to ignore whatever it's compounding by for now. Just put 3.9% per annum. And then it's saying it's compounding quarterly. So if I go down all the way, press tab by the way to scroll down fast. PPY and CPY. If I say 4, quarterly means 4 times a year. So that's really important to know as well. I change my PPY and CPY to 4. So if it's monthly, it's 12. If it's annually, it's just 1. So if it's fortnightly, it's 26, and so on. So the quarterly, PPY and CPY is 4. And then PMT at, you just never leave it on end, you ignore that completely. Then the number of times, so it's saying at the end of each quarter, immediately after the interest has been paid, she adds 200 to her investment. So remember, she's adding 200 to her investment. So she's giving to the bank $200. So she's negative again, 200. PMT, which is payment, I put negative 200 because the 200 is leaving her, going to the bank. Now I have N and FV that are still missing spots. So I need to fill those. There's only meant to be one thing missing. So the rest of the question says, after 2 years, the value of her investment will be closest to what? So this is, N is the number of times that this is occurring. So it's saying it's 2 years. So I put 2. However, it's saying compounding quarterly. So I multiply it by 4. So how to do this? N, the number of times. I say 2 years. So I find how many years it goes for. And then I multiply it by the number of times it's compounding. So it's a compounding quarterly, which means 4 times. If it's compounding monthly, I do 2 years times the 12 months. If it's annually, I do 2 times 1, and so forth. So 2 times 4, and you don't need to multiply that. The calculator does it automatically. 2 times 4 is 8. Click tab. Now, future value is the only thing we don't know, and it's saying after 2 years, the value of an investment will be what? So after 2 years, we want to know what the future value is in 2 years. So all I have to do is click enter here, and the value comes up straight away, and it's telling me that it's $7,059.25, and that is closest to D. So therefore, 23 is D is my answer. Sorry. Question 24. My invested in annuity earns interest at the rate of 5.2% per annum, compounding monthly. Monthly payments are received from the annuity. Balance of annuity will be $130,784.93 after 5 years. And balance of annuity will be $66,992.27 after 10 years. Monthly payment that Maya receives from the annuity is closest to what? So, to work this out, basically, it's saying that my original after 5 years is $130,784.93. So that is my present value. In 5 years' time, my future value, FV, is 66,000. So I want to try find the monthly payment. That's the unknown. So first we're going to fill in the obvious things. We know that the interest is 5.2% per annum, and it's compounding monthly, which means we're going to go to my PPY and CPY, put 12, tab, and then I'm back at the top. It's saying monthly payments are received. So the thing that I should have blank is PMT, my payment, because that's what I want to know. It's saying that after 5 years, this is my present value, the 130,000. And after 10 years, I have 66,000. So which means there is a 5-year gap, which means if I have 130k now, after 5 years, I'm going to have 66k. So 5 years, that's how I got the 5 from the number of the payments. 5 years times compounding monthly, yeah? Because it's going to take 5 years for me to get from 130k to 66k. So, calculator will do it automatically. Press tab, get to present value. My present value, remember I don't have it yet. This is in the annuity, it's with the bank, so it's negative $130,784.93. So that's my present value, and I know that the future value, which we said, is going to be $66,992.27. Okay, so some of you might be asking now, why haven't I put a negative in front of the FV? And that's simply because that's money that the bank owes me. Future value is mine. It's a bit confusing to get, but the FV, if PV is usually negative, FV is usually positive. So future value, I now have $66,000, so it's my money. So that's why that's positive. Now that we've done that, I simply go back up, payment, that's what we don't know, everything else is filled in, hit enter, and we get $1,500, and that is our monthly payment. Therefore, our answer is C.